everyone. Today we are going to study the part of buffer solution in the chapter of acid-base titration. The acid-base buffer solution can stabilize the pH of solution to a certain extent and range by reducing or eliminating the influence of adding a small amount of acid, alkali, or moderate dilution on the pH of solution, so as not to cause significant changes. Buffer solutions are of great significance and application in the fields of chemical engineering, analytical chemistry, agriculture, biochemistry, and clinical medicine. The classification of the buffer solution according to its function mainly includes controlling the pH of the solution and as a reference standard solution. The strong acid of high concentration generally used at pH less than 1, while the strong alkali of high concentration is used at a pH larger than 13. For complexometric titration of calcium ion, a high concentration of sodium hydroxide solution is used to control acidity. As a reference standard solution, the application range of buffer solution is also wide. For example, before using a pH meter, the instrument should be calibrated with standard solutions, and buffer solutions of pH 4.01, 6.8, 9.0 are required. Requirements for buffer solutions: 1. Possess both alkali-resistant and acid-resistant components. 2. Ensure weak acid and its conjugate base with a sufficiently large concentration and an appropriate concentration ratio. Common buffer systems include acetate, phosphate, ammonium, carbonate, and so on. Calculation pH in buffer solution. To common buffer solution, the equation of hydrogen ion is obtained by transforming the expression of Ka, which is derived from the dissociation equation of conjugate acid-base pair. Taking a negative logarithm on both sides of equation yields the calculation formula of pH. It is noted that when plus sign is in front of logarithm sign, numerator of the fraction is a concentration of conjugate base, and the denominator is acid. This is a formula to calculate pH of buffer solution used in middle school or college chemistry, also the simplest form. Take the case of C1 mol per liter HA, C2 mol per liter NaA to discuss the precise calculation of pH in buffer solution. Following the calculation steps of hydrogen ion in acid-base solution, first, separately write the PBE of acid and its conjugate base, and then substitute PBE into the simple formula to get the rigorous equation of pH. It is difficult to calculate the rigorous equation, so the simplification is necessary. When pH less than 6, the concentration of hydroxide ion is lower than 10 to the minus 8th power mol per liter, so it can be ignored to get the approximate formula. Similarly, in the basic range, the concentration of hydrogen can be ignored to get the approximate formula. When C1 way larger than hydroxide minus hydrogen and C2 way larger than hydrogen minus hydroxide, the approximate formula can be simplified to the simplest form, which is a common calculation formula of buffer solution. Let's have a look at an example. Standard buffer solution. Note, pH of standard buffer solution is determined by experiments. If pH is calculated theoretically, the ion strength must be considered. Table 5.1 listed some standard buffer solutions. That's all for today. Thank you.